I of 2 equals I of 3 equals I of 4, and however many resistors we have in the circuit, the current is going to be the same. It's not going to change. It's going to be our constant value. The total resistance of the circuit is going to be R1 plus R2 plus R3 plus R4, and however many resistors we have, right? Resistance in a series circuit adds up. We have to take the resistor values that we have, we add them up, or if we have the total, we subtract the resistors that we have, and then we can probably get a missing resistor value. E total, which is voltage, equals to the voltage of 1 plus the voltage of 2 plus the voltage of 3 plus the voltage of 4, etc. Power total in this circuit equals power of 1 plus power of 2 plus power of 3 plus power of 4. Also, depending on how many resistors we have, our power just adds up. Those are the rules for a series circuit. They're very simple, and this is the simplest one to be able to solve. Then we have to go into parallel circuits. So for parallel circuits, we actually have more than one path for current. Voltage is the same. So in a parallel circuit, our voltage is going to be our constant value. This is the one that's going to stay the same. So if we were to apply 10 volts to the circuit, 10 volts will be applied to each one of the resistors in the circuit. If we were to apply 24 volts to the circuit, then each one of the parts of that circuit will receive the same amount of pressure. This will be our constant value in this type of circuit. So drawing it out, we have a parallel circuit. In this circuit, we're going to have 3 resistors. We have resistor number 1, resistor number 2, resistor number 3, and I'm applying 24 volts to the circuit. So 24 volts are being applied right here. Our resistor number 1 is going to receive 24 volts. Resistor number 2 is going to receive 24 volts. And resistor number 3 is also going to receive 24 volts. So they're all going to be receiving the same amount of pressure. Now in this type of circuit, what happens to amperage is that it adds up. In our series circuit, the amps was our constant value. So if I were to give 5 amps to the circuit, 5 amps would apply to the whole circuit. In this case, if this resistor is using, for example, 5 amps, this resistor is using 2 amps, and this resistor is using 6 amps, in this type of circuit, my amperage adds up. So I'm going to go ahead, in order to get a total amperage for the circuit, I have to go ahead and get, just add these up, right? So this is going to be 13, right? So this is my E total, and my I total would be 13 amps, right? This is what happens to amperage in a parallel circuit. because we allow more voltage to be applied, then the amperage is higher in each one of those loads, and it adds up because of the way that we wired it. So my current right here goes in this direction, and it also comes here. At this point, it goes this way, and it also goes down. Here, it comes here. So current has more than one path to travel, and this is how we wire our homes. We wire all of our homes in parallel. And when we're wiring our circuits, we're actually we're bringing power from our home run, we're sending power to our next load, and we're also sending power to the resistor. In this case right here, this is our return leg, so we also are making, we're closing the circuit here, here, and here with this wire. So we would say amperage adds up in this type of circuit. Simple. If you guys are solving for a parallel circuit and the values are given to you for amperage, then you just need to add the amperages up to be able to get the total amperage. If you get the voltage is going to be your constant value, and you can apply it to each one of the resistors. For example, in this exercise right here, Ohm's law doesn't change depending on the circuit. Ohm's law stays the same. What is different between them are the rules that apply for each one of them. So in this case, I have 24 volts here, 24 volts here, 24 volts here. I have two values that I can use to be able to get the resistance for R1, resistance for 2, and resistance for 3. What would be the formula that we need to be able to solve for resistance here? If we have voltage and we have amperage, Ohm's law tells us
Voltage divided by amperage.
voltage divided by amperage, right? So 24 divided by 5, how much would that give me?
4.8.
How much?
4.8.
4.8? 4.8 ohms of resistance. And what would be the next resistance value?
Hour.
Here, it would be 12 ohms, and then here, it would be 4 ohms of resistance. Now, resistance doesn't add up in a parallel circuit, so I can't just take 4.8 plus 12 plus 4, because that's not how resistance works in a parallel circuit. It's very different. In order to be able to solve for resistance, we have 4 formulas that we can use. But what we have here is we have less resistance for the flow of current. So if I were to use my totals right here, and I were to get the resistance total of the circuit, what would be the total resistance of the circuit if I have 24 volts and I have 13 amps? I want everybody to do the math so that you can see what would be the total resistance of this circuit. 1.846 ohms of resistance. Very little resistance, right? a lot of current flows when we have a parallel circuit. We have less than the smallest. So one of the rules for a parallel is that the total resistance is smaller than the smallest resistor. The smallest resistor right here would be 4 ohms. And the resistance that we have for the whole circuit is 1.846 ohms of resistance. So that's why when we wire circuits in parallel, we have brighter lights. When we wire circuits in series, our lights dim because we actually divide the voltage, and each one of the lights will get just a little bit of pressure, each one of them. So there's a lot of resistance for the flow of current. Here, because current has more than one path to travel, and each one of the resistors sometimes will have a different resistance value, a lot more current can flow. 5 to 6 amps, and these resistances are something that we use in theory, but the ones that will figure out what's the resistance of the load is going to be the manufacturer. The manufacturer will make a resistor so that that microwave doesn't receive too much current when it turns on, or the refrigerator, or the coffee maker. So these resistors right here are something that the manufacturer is the one responsible to figure out. I want only 5 amps to flow through this, so I need 4.8 ohms of resistance, so only 5 amps can flow through the circuit. So this is what happens in a parallel circuit. We have very little resistance for the flow of current, so our current flow goes up, and our pressure is constant throughout the whole circuit. Remember that we call pressure the push, what allows electrons to move on our conductors. Voltage. Voltage is what's gonna give it the push, and then they're gonna start flowing through magnetism. They're gonna go, depending on the type of current that we're using. If we're using a battery, it's only gonna go in one direction. If we have alternating current, then it's gonna go back and forth 60 times per second. In this case, we have alternating current. This is how we wire most of our electrical installations, unless we're talking about low voltage. Okay, so what are what happens to power? So power, or total power, so for example here, I can get the power of this circuit by taking 24 for resistor number 1, and I'm gonna multiply it by the amps. That's gonna give me 120 watts. I'm gonna take 24 times 2, and that's gonna give me 48 watts. 24 times 6, that's going to give me 144 watts. Now, in order to get my power total, I just need to add these up. So that's gonna be 264 plus 40, that's gonna be 104 plus 8, 212, right? 212 watts. So power total doesn't change. We always add it up.
300.
312 watts, right? 312 watts. So what happens with our power is that we just add it up. It doesn't change. The same thing applies right here for our power in our series circuit. They just add up. This changed, and this changed. the rules change when we have a parallel circuit and when we have a, series circuit. So the only thing that stays the same is going to be the power. Now, remembering all of these rules is very important to be able to solve them so that we can figure out what happens to the values that are given to us in these types of circuits. So let's go ahead and do an exercise. So my power source right here is going to be a battery. I have two resistors. My battery is 24 volts. My resistor number 1 is 12 ohms. And my resistor number 2 is 24 ohms. Now remember, I told you that in order to be able to solve for resistance, we have 4 formulas that we have to use. So, formula number 1. R over N. Let's see. R total equals R over N. So when in a parallel circuit we have the same value of resistors, we take the resistor value and we divide it by the number of resistors. Formula number 2. R total equals R1 times R2 divided by R1 plus R2. This would be our formula number 2. If we have 2 resistors, we can use this formula. In our circuit that we have right here, we actually have 2 resistors. So I can't use this formula, but I can use this formula. We have a formula number 3, and we also have a formula number 4. But let's just go ahead and use formula number 2 for right now. So how is this formula applied? R total equals 12 times 24 divided by 12 plus 24. Okay. So let me get my total.
Mm.
12 times 24 gives me 288. 12 plus 24 gives me 36. So 288 divided by 36 gives me 8 ohms. So my R total equals 8 ohms. This is how we use our formula number 2. And we can only use formula number 2 when we have 2 resistors. That's it. 2 resistors, we use formula number 2. If we have more than 2 resistors, then we're going to jump into any other formula that we have. Okay, now that I have, for example here, I have my E total, which is 24. I have my R total, which is 8 ohms. Now I can go ahead and get my I total. I total would be 24 divided by 8, which would give me 3 amps. Power total would be 24 times 3.
72.
72 watts. All right, so I have all of my totals, but I still need to solve individually for R1 and for R2. Okay, so for this parallel circuit, my current has more than one path to travel through, and one of the rules for parallel circuits is that my constant value is our voltage. So I can take voltage and apply it to both of these resistors, because that's what one of my rules tells me for parallel circuits. Now I have two values here, and I have two values here. I can get the amperage for one, the amperage for two, the power for one, the power for two, and these have to add up to the total power and the total amperage of the circuit in order for my circuit to be solved correctly. Okay? So, just as a recap, we have two resistors, and because I have two resistors, I can use my formula number 2. How to apply the formula number 2 is to take both resistors and insert it into the formula that was given. Resistor number 1 times resistor number 2, resistor number 1 plus resistor number 2, and then those answers we divide them and we get the total resistance of the circuit. The total resistance of the circuit has to be smaller than the smallest resistor. So the smallest resistor in this circuit is 12 ohms. The total resistance is 8 ohms. So we're good. We're in the right path. So now I'm going to go ahead and solve for amperage. Using Ohm's law, if I have voltage and I have resistance, I take voltage and I divide it by resistance, and that will give me my amps. So 24 divided by 12 gives me 2 amps. Then 24 divided by 24, 1 amps. 2 plus 1
3.
gives me 3. Okay, now I'm going to go ahead and get my power. 24 times 2 gives me,
48.
and 24 plus 1 gives me 48 plus 24 gives me 72.
You propose
48
a watt.
volts.
Oh yeah, sorry. Hold on, let me just finish it here. There you go. So we have 48 watts plus 24 watts gives me 72 watts. So it all has to add up. We have to have a balanced circuit in theory, and then after we do our math, if we have the opportunity and we're doing the math because we want to go ahead and troubleshoot a circuit, with our measuring tools, we have to go ahead and measure that between these 2 points, I have 24 volts, and then around this wire, when the circuit is on, we have 2 amps flowing through this circuit, through this branch right here. We have 1 amp flowing through this branch right here. And if we were to measure resistance, this resistor has to be 24 ohms, this resistor has to be 12 ohms, and of course the wattage is just something that is measured in time, depending on what's being consumed. That the wattage is measured in time, in watt hours, and this is something that the electrical company will do for us. Now, we have tools out in the field where we can actually measure the wattage that's being consumed, but that's not something that we do too much. Most of the manufacturers will give us the wattage that the loads will consume, and that's how we can insert that into our Ohm's law and into our circuit calculations. Okay, so we have clear what are the differences between series and the differences between parallel circuits. There are a lot of differences. We have that current actually has more than one path to travel. Voltage is the same throughout the whole circuit. Our amps actually add up to this circuit. Our total resistance is smaller than the smallest resistor, and our power will add up. So, does anybody have any questions? Yes.
R over N within?
R over N, I'll give you guys an example right now on how to use R over N. So this is how we use our formula number 1, right? Now let's go ahead and see how we use this is how we use our formula number 2. So this is formula number 2. So how do we use our formula number 1? For example, we have resistors of the same value.
Same resistor. The same resistor.
It doesn't matter, of course it has to be more than 2, but it doesn't matter if our resistors are 3 or 4. And this is something that happens when we install lights, right? For example, all of my lights will be using R1, R2, R3, R4. Alright, so when we have resistors of the same value, we can solve our total resistance by using formula number 1, and we take the value of one of the resistors, because they're all the same, right? And then we divide it by the number of resistors. So we have 4 resistors right here, so 10 divided by 4 will give me my total resistance. Which would be like 2.5, right? So the total resistance of the circuit would be 2.5 ohms. It's very simple. You can only use this formula when all of the resistors have the same value. So you take the value of one of the resistors and then you divide it by the number of resistors. That's what that formula means.
So I see that you give us in every example the total voltage. So in every situation, we always get the total voltage?
No.
No?
No,
This is just.
this is just to ease you guys into this solving problem. You have to always remember what are the rules, and depending on what values you get, for example, if you get amperage on all of the resistors, you know that now you can add them up to get the total amperage. And then you have formulas to be able to solve for resistance, and then you can get voltage. So no, not in every operation you will get the pressure.
Okay,
It's just easier right now to be able to explain.
thank you.
Alright, so Jose, what would you do next here to be able to solve for the circuit?
Divide the voltage, the total amperage.
Get the total amperage?
Oh, yeah.
Okay, so what is the total amperage of the circuit?
Wait, what number is voltage?
What?
What number is voltage? I can't see.
60. Yeah, it's 60. Mm-hmm. That's gonna give me 24 amps, right? Now I can get my total power right here by taking 60 and multiplying it by 24, which would give me power total equals 1,440 watts. I have my total powers. Edgardo, what would you do? What else would you do here to be able to solve for each one of the branches there?
Power of each branch.
For resistor 1, divide
each branch.
60 over 10.
Only for resistor number one?
Oh, just
Oh.
to solve for that.
123.
Well, the easiest way right here would be to take 60 volts,
Yeah.
60 volts, 60 volts, 60 volts. Why? Because that's my constant value, right?
Yeah.
So because all of these have the same value, I only have to do the math once, right?
Yeah.
So
Yeah.
60 divided into 10 would give me how much?
6.
6
And
amps, 6 amps, 6 amps, 6 amps. 6 plus 6 plus 6 plus 6 gives me 24. And this is an easy operation. Why? Because all of the resistors have the same value, so I'm gonna get the same answer when I take 60 times 6 gives me
360. Volts.
right? 360 watts. Just because they all have the same resistance value. So when we get a circuit and all of the resistors have the same resistance, we can use our formula number one. Take one of the values of one of the resistors and divide it by the number of resistors. So where did I get this 4 from? 1, 2, 3, 4. That's where I got the 4. If it would have been 6 resistors, I would have taken 10 and divided by 6. Now, do all of the rules apply here? My voltage is constant. The total resistance is smaller than the resistance right there. Our power adds up and our amperage adds up. So we have a balanced circuit here. And we're using Ohm's law and we're following our rules for parallel circuits. Yes?
What if the ohms was the same for the first one? Would we use our second formula?
If we had, for example, 12 and 12,
Yeah.
you can use either or. So let's go ahead and figure that out. You can use one or the other. So if we were applying 24 volts into a circuit, they were 2, and this one was 12 ohms, and this one was 12 ohms. Go ahead and solve for resistance by taking 12 times 12, and then 12 plus 12, right? It should give you the same thing, because all of our formulas are taking us to the same thing. 12 times 12, and then 12 plus 12, right? If you wanted to use that formula, we're trying to solve for our total. So 144 divided by 24 gives me our total equals 6 ohms. Then I go ahead and take 12 divided by 2, and that gives me
6.
You see that? This is formula number 2, and this is formula number 1. So they should give us the same answer, right? But it's easier if we use this one. I have to do all that rest. So when you have these formulas, you gotta pick which one you're gonna use. Okay, it shouldn't give us a way different answer. Yes?
For formula number 1,
Mm-hmm.
can you have the same number of resistors as the total or the actual resistors? Power, I guess? Like 10 divided by 10?
Yeah, you could. That would be one ohm of resistance. It could be, yeah, it could be. It could possibly have that question in a test. And the thing here is that sometimes the numbers don't make sense for us, right? It doesn't really make sense that that I'm gonna have a larger number or a smaller number being divided by a larger number. But here, it doesn't really matter if it makes sense or not. You have to follow the rules, and whatever answer you get should be able to measure with the multimeter when you're looking at your circuits. So you guys are gonna see a lot of things that doesn't really make sense, but if you follow the rules and your circuit is balanced, it's just physics, right? It's physics, and all of this is theory, and when we do all of this math, this is something that already is calculated, and this is a design circuit. Now here, in some cases, I'm gonna be making up some numbers, but I can't forget, like I can go ahead and just make up resistor values and also put amperages, and my circuit is not gonna be balanced. I have to make sure that it makes sense theory.